for two different curves to find common tangents for two different curves. Assume for one curve and apply the condition for second curve and apply for second curve. This is the basic idea. The basic idea is assume the curve, two different curves, assume for one curve and apply for second curve. Now let us look at this, how to do this. In a circle, if I take x square plus y square is equal to a square, the tangent condition you should always remember, c square is equal to a square into 1 plus m square. So any tangent to the circle can be taken as y is equal to mx plus or minus a into under root 1 plus m square. Any tangent to the circle, note down. Any tangent to the circle, please note down. This is a very important thing. Very two steps you can do if you know this. But my a is root 2a. I will keep root 2a in the place of a. Y is equal to mx plus or minus root 2a into under root 1 plus m square. This is the tangent to this directly. I am giving you this outline. You should fill up. This is the tangent. Now this is also tangent to this. It is in the form of y square is equal to 4ax. A particular line y is equal to mx plus c will be a tangent to the parabola if c is equal to a by m. I am using capital letters so that you are not confused. C, y is equal to mx plus c, this is c, root 2a into under root 1 plus m square, that is c. This is equal to a is parabola of a, this is 4a, your a is 4a is 4, capital A is 8a, means your this is 2a by m. M is m only, I don't know. Now squaring it on both sides, 2a square into 1 plus m square is equal to 4a square by m square. Now a square is anyhow gone, this is 2 times 1 plus m square is 2 by m square, or m power 4 plus m square minus 2 is 0. What are the values of m square now? M square can be 1, m square can be minus 1. If you take m square is equal to 1, m is equal to plus or minus 1. Putting back m is equal to plus or minus 1 in the curve, what do you get? Y is equal to plus or minus x plus or minus root 2a into 1 plus or minus 1 square is 1 only, root 2. So y is equal to plus or minus x plus or minus 2a. These are the common tangents. These are the common tangents for the circle as well as the parabola. So look at this, y is equal to plus or minus x plus or minus 2a. What we did is conditions for all the four curves. You should remember the tangent conditions and then only it is easy to do. After that I have taken the tangent for circle and applied the condition for parabola. You can do the other way around also. You take a tangent for the parabola and apply the condition for the circle. In both the cases you get the one and same. So that is the important aspect. Now some of the locus problems are coming. Overall lesson preparation is some of the locus problems are being given. We will just discuss them. Please take a note of all the things which we have done and go through the lesson. We will once again discuss what all we have done. The most important aspect is, when you look at this for examination point of view, tangents, normals, parametric coordinates and conditions of tangents. These are the four important aspects: tangents, normals, condition of tangents, and similarly normals, parametric coordinates. So if you concentrate most of the time on these aspects, it is easy to score more marks. All the key concepts are taken, and tangent, once again I am repeatedly stressing tangents, normals, parametric coordinates, standard equation of the curves. And we, as after the concepts, we started doing some of the important questions. Now let me take up some more questions so that you will have a clear idea how to proceed. See, this question is find the equation of parabola whose focus is 3 minus 2. Find the equation of the parabola whose focus is 3 minus 2 and directrix is 3x plus 2y minus 4 is equal to 0. This is a very short answer question with good scope to get very simple. The focus is given and directrix is given. We have to find the equation of the parabola. So whatever the parabola may be, the focus is somewhere here, 3 minus 2. Let us take a point on the parabola pxy. So what is the property of parabola if your directrix is here? So SP is equal to PM for a parabola. SP means the distance between S and P. PM is the perpendicular distance from P to directrix. If you take P as xy, what is xp? X minus 3 whole square plus y plus 2 whole square under root. PM, the perpendicular distance formula, 3x plus 2y minus 4 by under root 13. This is exactly the only thing is your activity is only simplifying this. If you take this and square this, 13 into x minus 3 whole square plus y plus 2 whole square is 3x plus 2y minus 4 whole square. You should simplify it in a neat manner, and we leave simplification for you. Just in your notebook simplify this. You finally get ax square plus 2hxy plus by square plus 2gx plus 2fy plus c form, an equation of the form which is a generalized parabola. So our standard parabola is y square is equal to 4ax, but you will get a generalized parabola. Please follow this carefully. And now let me take the next one. Next question is for the ellipse. He is asking us for the ellipse x square plus 2y square. For the ellipse x square plus 2y square minus 4x plus 12y plus 4 is equal to 0. Look at this for the ellipse 14, sorry, constant should be careful. X square plus 2y square minus 4x plus 12y plus 14 is equal to 0. Find eccentricity. That is the question. Find eccentricity. We did a question of this model earlier. We have to convert this into standard form. For that all the terms of x here, and I will take 2y square plus 12y plus 14 here. This is, I can write it as blindly x minus 2 whole square plus I have a 4 extra, I will take from this 2 if I take common, y square plus 6y plus 9 if I write like this. Now 18 plus 4 22, and now look at the simplification please. 2 common, y square plus 6y plus for perfect square I am putting it as 9. What I am getting is I am getting 4, I am getting 18. 18 and 4, 22. I am having only 14. 14 can be written as 8 minus, please look at this, what constant we can keep here.